This playlist will collect together and organize the component modules of a second lecture on inferences and human inference abilities, covering material from that chapter 5 of our text. In this lecture, we'll start by looking at different kinds of strategies the cognitive scientists have identified as strategies that drive a lot of human inference and decision-making abilities. We'll then look at the relationship between these different strategies and categories of strategies, how they interact in real-world problem solving and decision making. So the first category that we'll look at and talk about are general heuristics. Then we'll turn our attention to context-dependent heuristics. Finally, we'll look at learned conscious problem-solving methods. Now, those first two categories, general heuristics and content-dependent heuristics, they are grouped together by cognitive scientists into what they call System 1. Now, System 1 is a terrible name because it has all sorts of bad connotations. It suggests that it's a single brain system or a single cognitive process, but it's not actually. System 1 simply refers to a general strategy for processing information in inferences and decision making that cognitive scientists have identified, and that they group those inferences together on the basis of their shared approach to processing that information. Learned conscious problem solving involving working memory is grouped into System 2. And as we'll see, System 1 and System 2 are complementary systems that interact with each other, though not as well and as often as we might like. After we go through those basic distinctions and the relationships between those systems in typical inferences and decision making, we'll turn our attention to that first category, general heuristics. And we'll talk about how general heuristics facilitate inference abilities, how they introduce certain inabilities, and particularly how they result in biases in the way that human beings make inferences and decisions. And to illustrate these abilities, inabilities, and biases, we'll introduce a heuristic that we've talked about in the past, the representativeness heuristic. And we'll talk about it in greater detail and use it as an example to illustrate these abilities, inabilities, and biases. Cognitive scientists can break human inference strategies into three general categories, three tiers, as it were. Now, the first tier is general heuristics. Inference strategies and decision-making strategies that are categorized as general heuristics are strategies that tend to be employed across a wide variety of contexts. So they are generally applicable. And they're heuristic in nature in that they are essentially fallible rules. Usually a heuristic is employed when you have a complex problem. And in order to get a tractable solution to that complex problem, you make an assumption or multiple assumptions about the problem or about the world. Those assumptions work a lot of the time, but they don't necessarily work all the time. And so a heuristic is a fallible rule or a fallible inference strategy. The second tier are context-dependent inference strategies. And these are inference and decision-making strategies that occur in specific contexts, but that don't occur generally, even when a problem could well be treated with one of these inference strategies. If it's not in the context that triggers that strategy likely will not be employed. Now, psychologists group these two tiers, these two strategies or general ways that we make inferences and decisions into what they call System 1. That's a terrible name, and any cognitive scientist will tell you that the name is misleading. It suggests that there's a single inference system or a single brain system that's responsible for all of these inference and decision-making strategies. But this isn't really what psychologists mean when they use System 1. What they're saying is that these strategies, the context-dependent heuristics and the general heuristics, they all share a general approach to processing information, to make inferences, and to make decisions. And so they're grouped together because they share a common profile of how they approach the inference or decision-making process, the sorts of information that they utilize, and the kinds of transformations that they make. A third tier would be learned or conscious problem solving or decision making. And in general, whenever we're using our working memory to solve problems, we're oftentimes employing rules or strategies that we've learned. These strategies, as we'll see, often tend to be highly decontextualized. And so psychologists and cognitive scientists group these strategies, these approaches to problem solving and decision making into a separate quote unquote system, a separate approach to processing information to make inferences and solve problems. With this taxonomy of two general strategic categories of inference and decision making strategies, with three different kinds of inference and decision making processes, we can now start to look at the relationships between them and ask ourselves how those relationships and how the use of these strategies impacts our overall inference and decision-making abilities. And this is where the lecture starts to get a little bit, depressing maybe. Because what we discover is that these system 2 processes, these processes with learned rules, that tend to be highly decontextualized and rely on fluid intelligence, they tend to be more reliable across contexts and problem variation. The inference and decision-making strategies that we're more likely to deploy in any given circumstance, however, goes in the opposite direction. We're much more likely to use a system 1 inference or decision-making strategy than we are to use a system 2 inference and decision-making strategy. And so the disposition, the general bias that we have is that we're more likely to use less reliable processes. Now, this doesn't mean that we're terrible at making inferences and decisions across the board. But as we'll see, these system 1 inference strategies are relatively rigid in their application. They make assumptions about the nature of the problem and the environment that are more often violated in contemporary society than they were during those periods of human and proto-human evolution. And so as a result, they have a reasonably significant negative impact on our overall inference and decision-making performance. In the next lecture module, we'll expand upon this last point. We'll look more carefully at the properties that cognitive scientists use to distinguish between System 1 and System 2 approaches to information processing. And we'll look at the relationships between System 1 and System 2 processes in real inference and decision-making contexts.